Hi everyone, my name is Dijkstra and I will be presenting our work on Wi-Fi-CSI sensing and bearing estimation in multi-robot systems, an open source simulation framework. Warehouse automation is driving the demand for autonomous robots capable of indoor localization. We study a class of localization problems, where radio frequency signals are used to obtain relative bearing information. Specifically, we study Wi-Fi, a widely accessible radio frequency protocol for indoor operations. We focus on multi-robot systems acquiring relative bearing information for localization purposes. Wi-Fi carrier signals amplitude and phase can be used to extract channel state information, or CSI. While amplitude data is typically coarse and noisy, phase data is highly accurate and reliable. Antenna arrays have been conventionally used to capture phase data of incoming Wi-Fi signals to estimate relative bearing. A moving robot can emulate an antenna array by intercepting multiple signals along its trajectory using a single antenna. The Wi-Fi Sensor for Robotics, or WSR toolbox, originally developed in 2022, provides the hardware and software tools for this operation using mobile robots. However, its operability is limited by its obsoleting hardware. In this work, we create a simulation framework that replicates the operation of real robots equipped with the hardware and software of the WSR toolbox. We use Gazebo for simulating the robots and MATLAB for operating the robots over ROS. 3 steps are included: simulating raw CSI data, computing signal phase and robot displacement, and running Bartlett's estimator to find relative bearing. We introduce imperfections into the theoretical signal model of CSI. These include carrier frequency offset to simulate real antenna deviations from the nominal carrier frequency, and Gaussian white noise to mimic multipath and other signal noise. We conduct real and simulation experiments. We use the Intel 5300 network card with an up-squared computer board on real robots and compare the CSI data and bearing estimation results. Here you see the videos of our simulation and real experiments, running a line-of-sight circular trajectory of 10 cm radius. Here we show the signal results comparing real and simulated experiments. The CSI phase data closely matches in the 2 different trajectories. The angle of arrival profile using Bartlett's estimator accurately captures the bearing in all circular experiments with considerable ambiguity in linear trajectories. The simulation shows only slightly more confidence and less irregularity in the grading lobes than the real experiments, which contain multipath and odometry inaccuracies. In conclusion, we presented a novel simulation framework that realistically captures the operation of the WSR toolbox in line-of-sight operations. This framework mitigates the obsoleting hardware issue of the original toolbox, ensuring its continued usefulness for future research. Thank you.